All right.
So my project was on DeFi, decentralized finance, specifically protocol economics and the currency exchange model that we'll be running. Okay. So first of all, the project that I dealt with was SWAPland. It is basically a decentralized NFT exchange platform. It's the first of its kind to use Near. It's like you know how there's like game engines like the Unreal Engine. It's kind of like that. It's still in its development phase. We basically need to work out what the economics of the trading is going to be. It's pretty much just another virtual storefront to trade NFTs. As you can see here, I've attached some images of the website and stuff. So I mentioned that Swapland is decentralized. So the difference between a centralized economy and a decentralized economy is that the centralized economy has one power in the middle controlling all the money and how it works. However, a decentralized one, transactions occur between people. There's no one central source of power. I kind of highlighted it right here. So the question that I decided to focus on for my research was, how do we reward those that contribute to the DAO? So basically the DAO is a decentralized autonomous organization. It's basically a democracy of the people in the exchange that decide what to do with the money, decide how to rule. It's not, yeah, so basically it boils down to no reward, no work. People have to be incentivized to contribute to the DAO, to do stuff. And if there's no reward for doing so, then they're not going to do the work. So the question I focused on was, what kind of economy would reward contributions while keeping inflation and other undesirable conditions minimal? So these token economies that Swapland and other exchanges are based on, they're modeled by smart contracts, which is basically just a lot of code, which is basically math. And mathematical models exist to simulate these economies. So I decided to focus on bonding curves. So basically a bonding curve describes the mathematical relationship between the token price and the token supply. It's simple economics. The token supply, of course, depends on the price, scarcity, demand, all that. And they take different shapes based on what your needs are. So I made this CAD drawing of the parameterization of bonding curves. So we first have the token metrics, what exactly the input, the variables in the bonding curve formula are going to be. I'm going to touch on that a little bit later, but it basically boils down to the token price and the token supply are inputted into the bonding curve, which can be expressed as a mathematical formula. And then the outputs are going to be your demand curve and the token value, the asset value. So I found that the issue with bonding curves is that traditional bonding curves are inflationary due to the nature of the power function. You know, as the power function approaches infinity on the x-axis, the y-axis also goes to infinity, which just means inflation. So my research focused on how to correct these issues and what shape the bonding curve of Swapland should look like based on the parameters and expected outcomes that Zane gave me. So it turns out that there are four main shapes that bonding curves can take. There's the sigmoid, the exponential, the logarithmic, and the constant. But what I found was that the sigmoid curve was the most important and the most optimal to use. So basically, this curve rewards early contributors. So as you can see, there's an inflection point in the middle where it changes, the slope of the derivative changes. So basically, what I found was that this inflection point was basically where it enters the mainstream. So let's pretend like this is Ethereum, for example. The early adopters of Ethereum, back when people didn't think that cryptocurrencies were a big thing, they would be rewarded highly in the first part of the bonding curve because the price to mint is far shorter than the price to gain tokens. So in that phase, it would be inflationary because they're trying to get more tokens in circulation. However, once it hit the mainstream, once like everybody started talking about crypto, then it inflects, and then there's less and less rewards as more people pile in. So basically, as I said, it rewards the people who jumped on the ship early. And I basically explored the mathematical analysis of this. So basically, they can be represented by two equations here. It doesn't really matter which, but the first one is the one that I found most useful. So I've defined the constants over here on the right. So A in this formula is basically the limit price you want as the token supply approaches infinity. So basically, what is the top level of what your price for every token is going to be? And then B is the point at which the curve inflects. So basically, this spot in the middle where it inflects would get shifted over to the right or the left. Basically, it tells you, no, you manipulate it to tell at which supply of tokens you want the reward to start going down. And then C is basically the slope of the curve, how steep it's going to be. So do you want it to taper off faster, or do you want it to taper off slower? Stuff like that. So as with most functions, you can use calculus on it. So if you integrate this curve, you find the cost to create and bond new tokens. So basically from point A to B, the area under the curve is going to be how much it costs the gas fee to create the new token. And then if you differentiate it, that's basically the slope. So that just tells you how much it would cost to bond a token at an instant along the supply curve on the x-axis. So I found this really cool simulation online. The computer science for this is actually very hard, but I did modify this package a bit. This is basically the output for it. It's basically a bonding curve simulation. This screenshot is just it in action. So this is actually a part of the code that I looked at. And then specifically what I did for the code was modify this right here. It's basically a behavior module that tells the people in the simulation what to do based on how many tokens they have or where they stand in regards to the bonding curve. So if you take a look here at the last 3 lines, if your self-belief is less than 0 and your self-tokens are greater than 0, that means you're basically bearish. So I say that if your self-currency is greater than 0, you're going to buy more on the bonding curve. And then I also put in a scenario where if you have more currency and you have a lot of tokens, you're going to want to sell. So I put a sell function in there. So my final recommendations based on my project are, so of course the bonding curve the simulation needs more work to get fully integrated with SWAPland. I do not have the necessary computer science background to do that, but Zane can basically just make use of the sigmoid curve. SWAPland is currently in initial development, so it's in the part of the curve where it's going to start going up. So, but that means it needs a lot of initial momentum. So we want to reward the people that come to SWAPland early. So we're going to use the sigmoid curve because that's going to be inflationary. They're going to have more rewards, etc. So Zane can basically just use the bonding curve simulation model as a starting point to model how the SWAPland economy will work. And that's basically it for my research this semester.